Welcome back to the functions unit. Today we're going to take everything that we've talked about so far and sum it all up and look at 4 different representations. So let's go ahead and get started with that right now. Welcome back to the functions unit. Today we're going to be talking about 4 representations. We're going to be looking at all the different pieces that we've learned, pull them together, and show how we could take one form of a function and make all the other 3. So starting at the first problem here, it says the amount of money in Nora's lunch account is represented by the equation shown. So we were given the equation, we need to make the word sentence, the table, and the graph. So since I've got some variables there and we're talking about a lunch account, I can probably figure out that the A is going to stand for the account or the amount of money in the account. So that's going to stand for A, and D is going to stand for the number of days, because every day that Nora buys lunch, that amount is going to go down, and that's why we've got a subtraction symbol there to show us that every day she buys lunch, the account is going to lose a little bit of money, and that amount of money is $4 per day. So let's put that in a word sentence that we can all understand. So we're going to say that there is $40 in Nora's account at lunch, or Nora's lunch account, depending on how you want to write it out. And she spends $4 every day on lunch. So there we go. So we know that Nora spends $4 every day at lunch, and that's represented in the total amount of money in her account. So now that we've got the word sentence and the equation, we need to make the table and the graph. So we could make the graph by using our slope-intercept form and graphing our equation, or we can take points and plug them into our graph once we've taken them and plugged them from our table into our equation. So let's do that. So let's select days. I'm going to start with 0 days, then we can select maybe 3 days later, maybe 4 days later, maybe 5 days later, and 6 days later to see how that turns out on our graph. So now that I've selected points, I need to substitute them in. So remember to substitute them. We're going to have A is equal to 40 minus whatever point that we're going to plug in. I'm going to choose 3 for this example, but we could have chosen any one in our graph. We're going to have to choose all of them eventually anyway. So I've got A equals 40 minus 4 times 3, which is 12. And 40 minus 12 is going to give me 28. So I know that for 3 days, she's going to have only $28 in her account. So now I can do the same thing with all of the other numbers. So if I plug 0 in, 4 times 0 is 0, 40 minus 0 is 40. So that makes sense. On the first day, she's going to have $40 or all the money in her account. I know if I plug in the 4 times 4 is 16. 40 minus 16 is going to give me 24. Then I've got 5 times 4 is 20. 40 minus 20 is 20. And the final data that I've chosen is 6 days. So 4 times 6 is 24. 40 minus 24 is going to leave us with just $16 left in our account. And now we have our table filled in. Now it's important that the days we selected are either 0 or positive values, because remember, there's no such thing as negative days. So that's not one of our choices. So hopefully we've selected positive days. So now that we've done that, we're going to plot our points on our graph. So we're going to take our first point there, which is 0, 40. So we're going to go up to 0 and over to 40. We've got 3 and 28, so 3 over and up to 28, 4 over and up to 24, 5 over and up to 20, and then 6 over and up to 16. So notice that our points made a line, so this is a linear equation for sure. So the question is now, do we need to connect our dots? And the answer to that is no, because remember, the values in between all these dots don't mean anything. There's nothing between day 1 and day 2. This is a discrete function, meaning that the points in the middle don't mean anything, as opposed to a continuous function, which we're going to talk about right now when you turn your paper over. All right, hopefully you turned your paper over all right. And here we are with a little less fun of a function where we're not going to be talking about a real-life explanation. We're going to be just talking about input and output. So they've given us the word sentence this time. They said the output is 2 less than 3 times the input. So the first thing that I'm going to do is I'm going to write my equation on that. So I'm going to go through and pick out the important things I know. So it says the output, I know that's y, is going to be equal 2 less than is going to make a minus 2, but remember that's going to send it to the back because of that less than there. 3 times, okay, so I'm going to have times 3 something, and the input, which is x. So I've gone through and I've taken out all the vocabulary words that I know, and now I'm going to use those information to construct an equation. So the output is y is 2 less than, so I know that's going to go to the back, and then 3 times the input, so 3x. So now that I have the equation, I can either make the table or make the graph. I'm going to use my option of making the graph because I'm going to use sweet slope-intercept form. So I know that the slope is the number next to the x, so I know that's my slope there, and I know my intercept is the -2 there, because when I'm talking about y equals mx plus b, the b stands for the y-intercept, and in this case, that's going to be -2. So looking down at my graph, I'm going to put a point at the y-intercept of -2, and then I know my slope is 3, or that's going to be 3 over 1. So I'm going to be going up 3 and over 1, so up 1, 2, 3 over 1, 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 and I know that it works the same direction the other way, 1, 2, 3 over 1, down 1, 2, 3 over 1, and I've run out of space on my graph. So now I have all my points on my graph, and now I can connect them because this is a continuous graph, because everything in between the points that I chose will work. It's just not a lot of fun to graph fractions, so I didn't pick any of those. But I'm going to go ahead and connect all of my points using a straight edge or a line tool, and I'm going to have arrows on the end of my line. So now that I've created my graph, now I just need to use my table. And that's very easy. I'm going to just pick points that are on the graph that I already did when I was counting along. So I know that 0, -2 is going to be one of the points on my graph because it's the y-intercept. So remember, that's always important. Pick the y-intercept. Easy choice there. Then I've got a point at 1, 1. Looks like I've got another point at 2, 4. And it looks like I've got a negative point at -1, -5. So see, I've selected points that were on my graph, and that was much easier than doing the substituting in part. I could have done that. I could have picked x's, plugged them in, multiplied by 3, and subtracted 2, but that would have been a lot of work. I would have had to do that 4 times. It's much easier to just count along the graph and then write the numbers that I found on the graph. That brings us to the end of this video, so if you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.